8. Body movement. Sit absolutely still. Observe the movements taking place in your body. You must be blinking your eyes time to time. Observe the movements in your body as you breathe. There are so many movements that happen in our bodies. When you are writing in your notebook, which part of the body are you moving? Or when you turn and look at your friend, different parts of your body move while you remain at the same place. In this example, you also move from one place to another. You get up and go to your teacher or to the school compound or go home after school. You walk, run, skip, jump, and move from place to place. Let us see how animals move from place to place by filling up table. After discussing with our friends, teachers, and parents, Bojo wonders about movements in plant. He knows they do not move from place to place, but do they show any other kind of movements? Table. How do animals move from place to place? Animal body part used for moving from place to place. How does the animal move? Cow, legs, walk. Human, snake, whole body, slither, bird, insect, fish. Do this and comment this. Walk, run, fly, jump, creep, crawl, slither and swim. These are only a few of the ways in which animals move from one place to another. Why are there so many differences in the way that animals move from place to place? Why is it that many animals walk while a snake slithers or crawls and a fish swims? 8.1. Human body and its movements. Let us look closely at some of our own movements to begin with before looking at all these varieties of movements in animals. Do you enjoy doing physical exercise at school? How do you move your hands and legs while doing a different exercise? Let us try some of the many movements our body is capable of. Bowl an imaginary ball at an imaginary wicket. How did you move your arm? Did you rotate it at the shoulder in a circular movement? Did your shoulder also move? Lie down and rotate your leg at the hip. Bend your arm at the elbow and the leg at the knee. Stretch your arm sideways. Bend your arm to touch your shoulder with your fingers. Which part of your arm did you bend? Straighten your arm and try to bend it downwards. Are you able to do it? Try to move the various parts of your body and record their movements in table. Why is it that we are able to move a few parts of our body easily in various directions and some only in one direction? Why are we unable to move some parts at all? Activity 1. Do this. Place a scale lengthwise on your arm so that your elbow is in the center figure. Ask your friend to tie the scale and your arm together. Now try to bend your elbow. Are you able to do it? Figure. Can you bend your arm now? Table movements in our body. Body part movement. Rotates completely, rotates partly or turns, bends. Lift does not move at all. Neck, yes. Wrist, finger, knee, ankle, toe, back, head, elbow, arm, yes. Do this and comment this. Did you notice that we are able to bend or rotate our body in place where two parts of our body seem to be joined together, like elbow, shoulder or neck? These places are called joints. Can you name more such joints? If our body has no joints, do you think it would be possible for us to move it anyway at all? What exactly is joined together at these joints? Press your fingers against the top of your head. Face, neck, nose, ear, back of the shoulder, hands and legs including the fingers and toes. Do you get a feel of something hard pressing against your fingers? The hard structures are the bones. Repeat this activity on other parts of your body. So many bones. Bones cannot be bent. So how do we bend our elbow? It is not one long bone from the upper arm to our wrist. It is different bones joined together at the elbow. Similarly, there are many bones present in each part of the body. We can bend or move our body only at those points where bones meet. There are different types of joints in our body to help us carry out different movements and activities. Let us learn about some of them. Ball and socket joint. Activity 2. Do this and comment this. Roll a strip of paper into a cylinder. Make a small hole in an old rubber or plastic ball under supervision and push the paper cylinder into it as shown in figure. You can also stick the cylinder on the ball. Put the ball in a small bowl. Bowl, ball, paper, cylinder. Figure making a ball and socket joint. Does the ball rotate freely inside the bowl? Does the paper cylinder also rotate? Now imagine that the paper cylinder is your arm and the ball is its end. The bowl is like the part of the shoulder to which your arm is joined. The rounded end of one bone fits into the cavity, hollow space of the other bone. Figure. Such a joint allows movements in all directions. Can you name another such joint you can think of, recollecting the body movements we tried at the beginning of this section? Ball and socket joint, hip bone, thigh bone. Figure, a ball and socket joint. Pivotal joint. The joint where our neck joins the head is a pivotal joint. Figure. It allows us to bend our head forward and backward and turn the head to our right or left. Try these movements. How are these movements different from those of our arms that can rotate a complete circle in? Pivotal joint. Figure, a pivotal joint. It is ball and socket joint. In a pivotal joint, a cylindrical bone rotates in a ring. Hinge joints. Open and close a door a few times. Observe the hinges of the door carefully. They allow the door to move back and forth. Activity 3. Do this. Let us look at the kind of movement allowed by a hinge. Make a cylinder with cardboard or thick chart paper as shown in figure. Attach a small pencil to the cylinder by piercing the cylinder at the center as shown. Make a hollow half cylinder from cardboard such that the rolled up cylinder can fit inside it easily. The hollow half cylinder with the rolled up cylinder sitting inside it allows movement like a hinge. Try to move the rolled up cylinder. How does it move? How is this movement different from what we saw with our constructed ball and socket joint? We saw this kind of figure, direction of movement allowed by a hinge like joint. Hinge joints of the knee. Movement at the elbow in activity 1. What we have constructed in figure is different from a hinge, of course, but it illustrates the direction in which a hinge allows movement. The elbow has a hinge joint that allows only a back and forth movement. Figure. Can you think of more examples of such joints? Fixed joints. Some joints between bones in our head are different from those we have discussed so far. The bones cannot move at this joint. Such joints are called fixed joints. When you open your mouth wide, you can move your lower jaw away from your head. Is not it? Try to move your upper jaw now. Are you able to move it? There is a joint between the upper jaw and the rest of the head, which is a fixed joint. We discussed only some of the joints that cannot part of our body. What gives the different parts of the body their different shapes? If you wanted to make a doll, what will you make first? Perhaps a framework to give the doll shape before making its outer structure, is not it? All the bones in our body also form a framework to give a shape to our body. The human skeleton is composed of around 305 bones at birth. The numbers of bones in the skeleton changes with age. It decreases to 206 bones by adulthood after some bones have fused together. This framework is called the skeleton figure. How do we know that this is the shape of a human skeleton? How do we know the shape of the different bones in our body? We can have some idea about the shape and number of bones in some part of our body by feeling them. One way we could know this shape better would be to look at X-ray images of the human body. Figure the human skeleton. Did you or anyone in your family ever have an X-ray of any part of your body taken? Sometimes when we are hurt or have an accident, doctors use these X-ray images to find out about any possible injuries that might have happened to the bones. The X-ray shows the shape of the bones in our bodies. Feel the bones in your forearms, upper arms, lower legs, upper legs. Try to find the number of bones in each part. Similarly, feel the bones of your ankle and knee joints and compare this with the X-ray images. Figure X-ray images of ankle and knees joint. Bend your fingers. Are you able to bend them at every joint? How many bones does your middle finger have? Feel the back of your palm. It seems to have many bones, is not it? Figure. Is your wrist flexible? It is made up of several small bones called carpals. What will happen if it has only one bone? Figure bones of the hand. Activity 4. Take a deep breath and hold it for a little while. Feel your chest bones and the backbone by gently pressing the middle of the chest and back at the same time. Count as many rib bones of the chest. The rib cage. Figure. As possible, observe figure carefully and compare with what you feel of the chest bones. We see that the ribs are curiously bent. They join the chest bone and the backbone together to form a box. This is called the rib cage. There are 12 ribs on each side of chest. Some important internal parts of our body lie protected inside this cage. Ask some friends to touch their toes without bending their knees, starting from the neck. Move your fingers downward on the back of your friend. What you feel is the backbone. It is made up of many small bones called vertebrae. The backbone consists of 33 vertebrae. Figure the rib cage is joined to these bones. If backbone was made up of only one long bone, will your friend be able to bend? Make your friend stand with bone hands pressed to the wall and ask her to push the wall. Figure the backbone. Do you notice two shoulder bones? Figure. Bones on the back are prominent where the shoulders are. They are called shoulder bones. Figure. Observe figure carefully. This structure is made of pelvic bones. They enclose the portion of your body below the stomach. This is the part you sit on. Figure pelvic bones. The skull is made up of many bones joined together. Figure. It encloses and protects a very important part of the body, the brain. We discussed many bones and the joints of our skeleton. There are, figure, the skull. Some additional parts of the skeleton that are not as hard as the bones and which can be bent. These are called cartilage. Feel your ear. Do you find any hard bony parts that can be bent? Figure. There do not seem to be any bones here, is not it? Do you notice anything different between the earlobe and the portion above it? Figure. As you press them between your fingers, figure. Upper part of ear has cartilage, figure. The earlobe. You do feel something in the upper parts of the ear that is not as soft as the earlobe but not as hard as a bone, is not it? This is cartilage. Cartilage is also found in the joints of the body. We have seen that our skeleton is made up of many bones, joints and cartilage. You could feel, bend and move many of them. Draw a neat figure of the skeleton in your notebook. We have learned about the bones in our body and about joints that help us move in different ways. What makes the bones move the way they do? Let us find out. Make a fa Make a fist with one hand, bend your arm at the elbow and touch your shoulder with the thumb. Figure. Do you see any change in your upper arm? Touch it with the other hand. Do you observe a swollen region? Is the upper arm? This is a muscle. The muscle bulged due to contraction. It became smaller in length. Now bring your arm back to its normal position. What happened to the muscle? Is it still contracted? You can observe similar contraction of muscle in your leg when you walk or run. Figure. Two muscles work together to move a bone. When contracted, the muscle becomes shorter, stiffer, and thicker. It pulls the bone. Muscle works in pairs. When one of them contracts, the bone is pulled in that direction. The other muscle of the pair relaxes to move the bone in the opposite direction. The relaxed muscle contracts to pull the bone towards its original position while the first relaxes. A muscle can only pull, it cannot push. Thus, two muscles have to work together to move a bone. Figure. Are muscles and bones always required for movement? How do other animals move? Do all animals have bones? What about an earthworm or a snail? Let us study the manner of movement, that is, the gait of some animals. 8.2 Gaits of animals. Earthworm. Activity 5. Do this. Observe an earthworm moving on soil in a garden. Gently lift it and place it on a piece of blotting or filter paper. Observe its movement figure. Then place it on a smooth glass plate or any slippery surface. Observe its movement now. Is it different from that on paper? In which of the above two surfaces do you find that the earthworm is able to move easily? The body, the body of an earthworm is made up of many rings joined end to end. And figure movement of earthworm. Earthworm does not have bones. It has muscle, which helps to extend and shorten the body. During movement, the earthworm first extends the front part of the body, keeping the rear portion fixed to the ground. Then it fixes the front end and releases the rear end. It then shortens the body and pulls the rear end forward. This makes it move forward by a small distance. Repeating such muscle expansions and contraction, the earthworm can move through soil. Its body secretes a slimy substance to help the movement. How does it fix part of its body to the ground? Under its body, it has a large number of tiny bristles, hair-like structure projecting out. The bristles are connected with muscle. The bristles help to get a good grip on the ground. The earthworm actually eats its way through the soil. Its body then throws away the undigested parts of the material that it eats. This activity of an earthworm makes the soil more useful for plant. Snail. Activity 6. Observe a snail in your garden or in field. Have you seen the rounded structure it carries on its back? Figure. Figure snail. A snail. This is called the shell and it is the outer skeleton of the snail but is not made of bones. The cell is a single unit and does not help in moving from place to place. It has to be dragged along. Place the snail on a glass plate and watch it. When it starts moving, carefully lift the glass plate along with the snail over your head. Observe its movement from beneath. A thick structure and the head of the snail may come out of an opening in the shell. The thick structure is its foot, made of strong muscle. Now carefully tilt the glass plate. The wavy motion of the foot can be seen. Is the movement of a snail slow or fast as compared to an earthworm? Cockroach. Activity 7. Do this. Observe an cockroach figure. Cockroaches walk and climb as well as fly in the air. They have the three pairs of legs. This helps in walking. The body is covered with a hard outer skeleton. The outer skeleton is made of number of plates joined together and that permits movement. Figure a cockroach. There are two pairs of wings attached to the body behind head. The cockroach have distinct muscle. Those near the legs move the legs for walking. The body muscle move the wings when the cockroach flies. Birds. Birds fly in the air and walk on the ground. Some birds like ducks and swans also swim in water. The birds can fly because their bodies are well suited for flying. Their bones are hollow and light. The bones of the hind limbs are typical for walking and perching. The figure skeleton of a bird. Bony parts of the forelimbs are modified as wings. The shoulder bones are strong. The breastbones are modified to hold muscle to uplight, which are used to move the wings up and down. Figure. Fish. Activity 8. Do this. Make a paper boat, put it in water and push it with one narrow end pointing forward. Figure A. Did it go into the water easily? Now hold the boat sideways and push it on into the water from the broadside. Are you able to make the boat move in water when you push it from this side? A. B. Figure. Playing with boats. Figure fish. Have you noticed that the shape of a boat is somewhat like a fish? Figure. The head and tail of the fish are smaller than the middle portion of the body. The body tapers at both ends. This body shape is called streamlined. The shape is such that water can flow around it easily and allow the fish to move in water. The skeleton of the fish is covered with strong muscle. During swimming, muscle make the front part of the body curve to one side and the tail part swings towards the opposite side. The fish forms a curve as shown in figure. Then quickly the body and tail curve to the other side. This makes a jerk and pushes the body forward. A series of such jerks make the fish swim ahead. This is helped by the fins of the tail. Figure movement in fish. Fish also have other fins on their body which mainly help to keep the balance of the body and to keep direction. While swimming, did you ever notice that underwater divers wear fin-like flippers on their feet to help them move easily in water? How do snakes move? Have you seen a snake slither? Does it move straight? Figure. Snakes have a long backbone. They have many thin muscles. They are connected to each other even though they are far from one another. Muscles also interconnect the backbone, ribs and skin. The snake's body curves into many loops. Each loop of the snake gives it a forward push by pressing against the ground. Since its long body makes many loops and each loop gives it this push, the snake moves forward very fast and not in a straight line. We have learned about the use of bones and muscle for the movements of different animals. Paheli and Bujo. have many questions in their sex about the different movements in animals. So must you have been many unanswered questions buzzing in your figure movement in a snake minds? The ancient Greek philosopher Aristotle, in his book Guides of Animals, asked himself this question: why do different animals have the body parts that they do have, and how do these body parts help animals to move the way they do? What are the similarities and differences in these body parts between different animals? How many body parts are needed by different animals for moving from place to place? Why two legs for humans and four for cows and buffaloes? Many animals seem to be having an even number of legs. Why? Why is the bending of our legs different from that of our arms? So many questions, and perhaps we have looked for some answers through our activities in this chapter. And we need to look for many more answers. Yoga for better health. Yoga is an invaluable gift of the ancient Indian tradition. The United Nations declared 21 June as International Day of Yoga. Yoga keeps a person healthy. It helps in keeping the backbone erect, enabling you to sit straight and not slouch. Many postures in yoga require you to lift your own weight, which helped in making the bone strong and help ward off osteoporosis. It also helps in relieving joint pain, which is mostly observed in elderly people. It tunes all muscles in the body and keeps them active. It keeps the heart healthy and makes it work more efficiently. Certain yoga postures should be performed under the supervision of a trained person. Keywords: backbone, ball and socket joint, bristle, cartilage, cavity, fixed joint, guides of animals, hinge joint, muscle, outer skeleton, pelvic bones, pivotal joint, rib cage, shoulder bones, skeleton, streamlined. Summary: bones and cartilage from the skeleton of the human body. It gives the frame and shape to the body and helps in movement. It protects the inner organs. The human skeleton comprises the skull, the backbone, ribs, and the breastbone, shoulder and hip bones, and the bones of hands and legs. The bones are moved by alternate contraction and relaxation of two sets of muscles. The bone joints are of various kinds depending on the nature of joints and direction of movement they allow. Strong muscles and light bones work together to help the birds fly. They fly by flapping their wings, fish swim by forming loops alternately on two sides of the body. The snake slither on the ground by looping sideways. A large number of bones and associated muscle push the body forward. The body and legs of cockroaches have hard covering, forming an outer skeleton. The muscle of the breast connected with three pairs of legs and two pairs of wings help the cockroach to walk and fly. Earthworms move by alternate extension and contraction of the body using muscles. Tiny bristles on the underside of the body help in gripping the ground. The snails move with the help of a muscular foot. Exercises: do this and comment this. Things to think about. We discussed the many movements our body are capable of. Healthy bones, muscle, joints, and cartilage are needed by the body for all these movements. Some of us suffer from conditions that could make these movements not so easy. In a whole class activity, try to find ways that one would manage everyday activities. If any of our body movements was not possible, in activity 1, for instance, you tied a scale on your arm and disabled the elbow movement. Think of our ways of restricting normal body movements and find ways that everyday activities could then be managed.